So here I am, and I'm going to be using a graphing calculator, or rather I'm just using Wolfram Alpha because it's a little bit more visual for these videos. I would like to approximate the sixth root of 2. Now, some calculators might not be able to calculate sixth roots directly. And even if your calculator can calculate the sixth root of 2 directly, you might wonder how it is your calculator is able to do that. So I want a function f of x which has a root at the sixth root of 2. So I can just say that x to the power 6 minus 2 definitely has a root where I want to find it. And I also need the derivative of this function in order to use Newton's method. Derivative is going to be 6x to the power 5. Well, okay. When I go to iterate, I need to start somewhere. I need to start with some kind of a guess. And I'll start at x equals 1. I know that 1 to the power 6 is 1, and that's not a very good approximation to 2, but it should be close enough. Now, each time that I make one of these guesses, it's going to be off by a little bit. The formula that I use to correct my guess and get a little bit closer is what I've got typed in right here. I take the old guess, I subtract off the original function evaluated at that guess, divided by the derivative of that function evaluated at that guess. And the very nice thing about Wolfram is I can just put a semicolon here and tell the computer what number I want x to be. So let's have x equals 1 and see what we get. So my first guess here is 7 divided by 6. So let me go ahead and write my first guess was 1. My second guess was 7/6, or that's about 1.16 repeating. It's exactly 1.16 repeating. It's the 6's that repeat, not the 1. Let me go again. X equals 7/6. My next guess will be this fraction. 681,557 divided by 605,052. Well, that's a bit much even for me. So let's just call that 1.12644. Second guess is 1.12644. That's what I will put in here. And the very nice thing about this method is we just keep on going until we get something better than we started. So here's my third iteration. So that gives me my fourth guess. I can improve my fourth guess by putting that into the formula, running it again. There is my fifth guess. And just like we saw with limits at the very beginning of this class, this is looking like it's starting to settle down. So let me run that through one more time. And at least according to the computer here, I got the same number back. So just to double check, I should be able to take this number, 1.12246, raise it to the power 6, and I'm supposed to get something close to 2. Oh, I did get something close to 2. I got almost 2, but I am incorrect at the 10,000th place. So using Newton's method and just iterating, how many times did I iterate? once, twice, 3 times, 4 times, and then after 4 times was beyond my computer's ability to, keep going, because these just look like the same number to me. That's all I had to do to find something, if not exactly equal to the 6th root of 2, then very, very close.